Today, I'm combining a lot of things to consolidate your idea. Based on the questions you'll be asking, that is what helps me to be able to explain things further for you. Because of the enormity of the content, I'll try to make it simpler. And hopefully, if there's time, we'll start support vector classifier or support vector regression, if there's time. If not, we'll do that next week. So you all know what classification is. Okay. Classification, the goal is different from clustering. Now, who can think about the difference between classification and clustering? Let's quickly clarify that. In your view, based on your knowledge, based on all this learning you've been doing for the past almost 10 months, what do you perceive to be the main difference between classification and regression? You raise your hand, and then we address it. Okay, so look at this. A classification correctly predicts the class of a new unseen data. And normally the method you use for the classification is called classifier. So you can have discriminant analysis classifier. You can have naive-based classifier, support vector classifier, quadratic discriminant classifier, logistic regression classifier, and so forth. It's not the same as regression because classification looks at categories, regression looks at continuous data. So if you take regression like this, regression will be predicting a house price, which is numerical. Classification will be predicting whether a loan would default or not, which is categorical. And a typical example is classifying whether an email is going to be a spam or not a spam, whether a bank loan is going to be default or not default, whether a patient is going to have cancer or not have cancer, whether a student will pass or fail, whether a country is developed or not developed. Now, the idea focuses more on probability, not just on a specific number. So you can have the categories like 0 or 1, yes or no, and so forth, even multi-class. But it is based on the probability that if I should pick an observation, that observation will belong to that class. Now, the difference between classification and clustering is this. Classification is supervised. Clustering is unsupervised. Classification, the labels are known. You already know ahead of time that there is a default group and a non-default group. You have the labels. But in clustering, you don't know them. You are rather going to put them together into the labels. And then in classification, you are using classification to predict a predefined category. But then you are using clustering to discover groupings. Find clearly the difference. Know the difference. Know the difference between classification and clustering. All right. The problem with having a group is that instead of saying that a particular transaction is fraudulent, it's better to add a probability, the chance of it being fraudulent. So you can say that there is an 82% chance that this transaction is fraudulent instead of simply saying that transaction is fraudulent. And then you apply a threshold, say 50%. So anybody that is above 50% is classified as default. Anybody that is below 50% is classified as non-default. In the process of doing classification, you will encounter problems. One problem is overfitting, underfitting, imbalanced classes. You know all of these. If you don't know them, overfitting, underfitting, imbalanced classes, you raise your hand, we explain it to you. Okay. So the data that we looked at the last time, I'm going to make it simpler now so that you can get a full beginning before you get the end that we looked at. Suppose you have a group, okay, two groups. One is a default group or the other is a non-default group. The chances that a patient or a customer is going to default in the loan, that chance could be dependent on the income of the person. So if the person's income is, say, 3,000, the debt ratio of the person is 60%, the model can output the probability, and this is important, not just the actual, the probability that the person will default to be 78%, because there are several people. So if your income is 3,000 and the debt ratio is 60%, you can say that there's 78% chance that the person will default instead of saying that the person will default. And that is important. I'm interested in that probability angle. Why? Because probability gives confidence measure. It gives ranking ability. And without it, you get a very rigid classification. That is, either it is or it is not. But you have to choose a threshold, which we just did. We said that anything that is above 50% is going to be classified as default. Anything below 50% is going to be. Who told us to use the 50%? Who told us? Well, the thing is that, if both classes have the chance of equally likely to happen, then 50% is a natural point to do. That's a natural point to stand. Because yes, when a person is coming, you can start with the chances of the person going to default to be 50%. And the chances of the person not defaulting is 50%. In terms of transactions, you can say that the chances are going to be 50-50 for the transaction to be fraudulent or legitimate. But that is not always true, that 50% is the best. Because in fraud detection, if you use 50%, you miss fraud cases. You miss. Why? Because with them, when you bring the threshold down to, say, 30%, then you can catch those that are fraudulent more. And that will introduce the trade-off. Because when you bring the threshold down, it means that you are also moving in favor of one. That is the 0. If you take it up to, say, 0.8, you're also moving in favor of 1, which is not defaulted, or which is defaulted. So it brings that sort of trade-off. I've already mentioned the methods, the classifiers. Okay, and the last time we looked at a few of them, but today we'll dig deeper into the logistic and then understand, because once you understand everything about that, you can use it for the rest. The rest are only coming in for comparative purposes, using the confusion matrix, using the ROC, and then AUC, and then the precision recall curve and all of that. So those are the classifiers. But I'm more interested in showing you how the classification is done and how the evaluation is done. So take, for example, the probability that a person will default a loan, which is what you have here. The chances that a person will default a loan is going to be dependent on whether the person is a student or not a student, the balance, okay, the credit card balance, and the income of the person. Okay. Our interest, of course, this is qualitative, as you know. It's categorical. Our interest is to predict whether anybody who joins or who comes into this arena will default on his or her credit card payment. But that is contingent on the income of the person as well as the balance of the credit card of the person. It's based on that. Of course, you can see that I have student there. You can even omit the student for now. After you've done all the arrangement and you've calculated everything, you need to check whether the performance of the model is good. You need to check whether the model has been able to properly classify the people as default and not default. Whether the model has properly classified an email as spam or not a spam. Whether the model has been able to classify, whether a person will churn or will not churn. Whether the model has been able to classify whether the transaction will be fraudulent or will be legitimate. That's the goal. So the performance evaluation is finding the model's ability to correctly classify the records using the available predictive elements or the predictors. And that is what the interest is. Your ability to interpret the outcome of the model is more important than just the model. How do you assess the performance of a classification model? It doesn't matter. It doesn't matter. It doesn't matter which particular classification model you are dealing with, whether you are dealing with a naive classifiers, whether you are dealing with discriminant analysis, whether you are dealing with, quadratic discriminant, linear discriminant, k-nearest neighbor, additive models like random forest, decision trees, adder boost, cat boost, support vector. It doesn't matter. It doesn't matter. The key point is, since they are dealing with classification, we need to know whether the model is good or it's not good. And how do you know that? What tells you that the model is good or it's not good? It's a confusion matrix. The confusion matrix is what tells you. My goal is to walk you through the confusion matrix, understand it fully, and then pull out from the confusion matrix the accuracy measures. And then pull out from that the AUC and then the ROC. And then from there, we'll go and practicalize it. What is a confusion matrix? It's also called classification matrix. Why is it called confusing? Well, the confusion matrix is a 2x2 matrix that correctly, and that summarizes the correct and incorrect classification. Any of them that a classifier produced from the data. The classifier has produced labels such as 0 and 1. Once you have the labels, you can now find out how many predictions were correct, how many were incorrect, and what mistakes were made. And that's where the confusion comes in. So let's look at some two classes. Pay attention here. The first class is class 1, C1. The second class is class 2, C2. Now, guys, pay attention. Now, we are taking an example of loan default. Now, one of them, a class, is called C1, and it is positive. What does that mean in terms of the positive? The positive here is what you, the researcher, you are expecting. So the positive is that the person has defaulted. Take note. The negative is that the person has not defaulted. Take note. So suppose you are expecting that a person has defaulted, or that you're expecting the person to default and the person default, then you are happy that a person has defaulted. And that is why it is called true. It's true, positive. Now, why is it true? It's true because you predicted that a person was going to default, and the person actually defaulted. Therefore, true positive is always in the diagonal section here. That is why you predicted that that person is going to default. And the person truly defaulted. So here you predicted that a person is going to default, the person defaulted. But if you predict Let me talk about the next one before we go to the two difficult ones. If you predict that a person is not going to default, that is a C2, and the person did not default, that is C2, then you have also done a good job. That is true negative. So know the difference between the true positive and then the true negative. The extreme guys are the one that bring much of the confusion. For example, you predicted that the person is not going to default, and yet the person defaulted. The person has defaulted. And so you were wrong in your prediction. Now remember, you predicted that a person is not going to default. That is negative. And yet the person defaulted. That is, false. So in other words, you have made a mistake in your negative prediction. And therefore you have a false negative. But what if you predict that a person is going to default here? And the person did not default. Now, default is positive from here. And so you're going to have a false positive, wrongly predicting positive and not getting the positive. Write this matrix. Write this confusion matrix down. Write it down. The TP, use only the acronyms. So you have the predictor class at the top here. You have the actual class at the far left here. Then do C1, C2 at the top, C1, C2 at the far left. And then write your TP, the true positive, the true negative, then your false negative and the false positive and the false negative. The false positive here and the false negative there. Write that table. You will need it very soon. We're going to do some tests. Okay. So if you've been able to write that table, raise your hand. If you've been able to draw the table, raise your hand and let me see. I want to be sure. Raise your hand and let me be sure that you've been able to write this table in your book, because you're going to do a test and you'll be referring to the table. I have 7 people. I want everybody to be able to do this. By the way, there's a huge complaint about your cohort. Almost all of the cohort. A huge complaint. All the lecturers are saying that. Okay, let me keep quiet for now. How many people have raised their hand to indicate that they've done it? I'm waiting. "16 people have raised their hand, but the rest are yet to." I'm waiting. All right, okay. So I have 22 people so far. I'm just taking note of those who have it. Derek, Eugene, Eira, Michael, Ankra, and Peter. These are the people who are not in my class. They are the ones who are not in my class. Okay. So now with that in mind, let's proceed. It can be anything. Default, it can be diseases, can be transactions, can be email, anything. The confusion comes in because the model can tell you that the thing is positive when it's actually negative. That is, the confusion comes in with the false negative and the false positive. But we're going to handle it. You should be able to get it. And I pray that you don't also have that confusion. Please lower your hand. I'm just taking note of those who did it. These concepts that we're about to look at in confusion matrix, which is mainly used for classification models, after you've gotten the confusion matrix, you can now calculate the evaluation matrix. They include accuracy, precision, recall, F1, and there are even two others. We're going to use them for that. Let's start with the first one. One of the two others. The first is a mixed classification rate. Mixed classification rate. Please, just ensure that you are writing the formula. That's all I want you to do. So write a formula for the mixed classification rate. It's a false negative plus a false positive divided by the sample size. Write a formula for the accuracy. The accuracy is 1 minus the mixed classification rate. And the sample size here that you see, okay, this sample size that you see here is the same as the total positive and the total negative. Basically, it's a sample size. And so this formula and the one above, they are the same. That is called the accuracy. The accuracy is the first one, but it's not the ultimate. It's the first of the metrics. Remember, metrics here are like talking about the R square. We know the way we use the R square as a metric to judge the power of the model. We are using these accuracies to judge the power of the model. The accuracy is true positive plus true negative divided by the total positive plus the total negative. It is measuring the cases that were correctly classified. Correctly classified. Correctly classified. That's why it's known as accuracy. The next one is precision. Write the formula down. Precision. Write only the formula down. The formula. What is the difference between accurate? You see, accurate, you can be accurate, but you're not precise. You can be accurate. For example, let's look at transactions. You can say that of all the transactions that were, flagged as fraud, how many were actually fraudulent? Of all the transactions that were classified as fraudulent, how many were actually fraudulent? That is precision. That is not accuracy. So you can be accurate and not precise. And so precision measures how many of the positive predictions were correct. It measures the accuracy of the predicted model to correctly classify any particular class. So you cannot only rely on accuracy that we looked at. You also have to top it up with precision. Then there's a third one, the recall or the sensitivity. You see, precision is saying that of all the transactions classified as fraudulent, how many were fraudulent? But then recall is saying that of all the fraudulent transactions, how many were detected? How many were detected of all the fraudulent transactions? So recall is, like I said, sometimes called sensitivity. It is telling you the percentage of one particular group members that were classified correctly or correctly classified. So watch the formula for the recall and then look at it with precision, and you will see that there is a sort of a trade-off there. If you watch carefully, at the top there, you have true positive. At the down, you have true positive. Then there is a false negative added to the denominator. Now go to precision. At the top, you have true positive. At the down, you have true positive. But added to that denominator is a false negative. Now, added to the denominator here, added to the precision denominator is a false positive. And added to the record denominator is a false negative. Do you see that? Now, false negative and false positive, they are in opposite direction. Do you know that? So when you have a false positive and you have a false negative, when one is rising, the other is falling. So when you have false negative going up, the whole of this will fall down. And when you have this going, because remember, when false negative is going up, this false positive is going down. And when false positive is going down, the whole of this rises. But when false negative is going down, the whole of this falls. Oh, sorry. When false positive negative is going up, the whole of this falls. So take note, they are in a trade-off position. The record and the precision. The next one is the specificity. Not sensitivity, but specificity. It measures how many of the actual negatives were predicted correctly. In other words, first of all, we said of all the fraudulent transactions, how many were actually fraudulent? That's precision. Now, this one, of all the legitimate transactions, how many were correctly accepted? So check it. You will see that this one, specificity, carries a similar knowledge with precision, but in an opposite. Okay, so look at precision. Everything about precision here, you still have false positive at the bottom, but the only thing is that you have true positive and true positive down as well. Now, when you go to specificity, you have true negative, but then the false positives are the same for both of them. So you got to be able to understand and appreciate specificity, okay, and that of precision. The final one is F1 score. We've already said that accuracy is not enough, and it's not even enough, especially when the data is imbalanced. And the data is usually imbalanced when it comes to classification data. Most of them are imbalanced because majority, let's say that out of the students of Legon who passed, okay, every year, the number who passed and the number who don't pass, who are more? Who are more? Those who pass and those who don't pass, who are more? Obriyeboa.
Prof, those who pass.
Okay. Now, those who pass, are they significantly most of the time more than those who don't pass? Or they are usually 50-50? What do you say? Nah, they.
Doc, they are mostly around the same.
The people who pass, or you are one of them, you are saying around the same. The people who normally pass and the people who normally fail, they are around the same number. So if there are 1,000 people, 500 will pass, 500 will fail. Kus. Kofi, continue. I think your internet is not working. Anyway, so most of the time, the number that pass are way more than those that fail, generally. Take, for example, going to deliver. The number of people who deliver at the hospital, okay, those whose child will die, okay, if your child will die versus if your child will live, which ones are more? More, most of the time. Those whose children will live, okay, the living one will be more, way more than the dying ones. That's relatively speaking. And that's what brings about imbalance. Because imbalance is when the minority class are very minor and the majority class are very major. That's it. That's the whole point. The minority class are very minor, the majority class are very major. And what the F1, and so because of that imbalance, there is a problem between precision and recall. I told you that there is a kind of a trade-off between precision and recall. And so what the F1 score does is to harmonize the precision and recall, and by using a harmonic mean. That is why F1 score is just the product of the precision and recall and the addition of the precision and recall multiplied by 2. And simple. The reason is because precision and recall trade-off. Okay. So with all this in mind, please write this formula too in case you haven't written it for the F1 score. So now that you have gotten this thing, we are going to take a typical example. You're going to do this class and you're going to give me a quick answer. Okay. As soon as possible, you're going to give me a quick answer. So the first thing is to classify 1. Look here, classify as 1 if the probability is bigger than 0.5 and 0.5 threshold. So we have some actual defaults and then we have some predicted defaults here. You pick any of the defaults and if the predicted default, and if the probability, and we have chosen the 5 threshold, if the probability predicted or the predicted probability is bigger than 0.5, then this predicted probability will be reclassified as 1. But if it is lower than 0.5 or it is 0.5, then these predicted probability will be lower than, will be classified as 0, or it will not be available at all. The 0 here means it's absent. The presence here means it's present. So let me do the first one for you. Okay. So let's take the first one. The first one here, the number for the first, this is for the first customer, as you can see. So the first customer out of the 10 customers, the first customer comes, we have a predicted probability that this customer is going to default 90% of the time. There is a 90% chance that this customer is going to default on the loan. Now, this customer will be classified as what number? Who can tell me? This customer will be classified as what number then? Raise your hand and tell me. Magnus.
1, bro.
1. Let's take the last one here. The customer 10 will be classified as what number? Hatiat.
0.
0. Remember, I'm giving marks here in my recording. 0. So now I want you to recreate the table and then fill in all this right column for the predicted probabilities. Once you are done, raise your hand. Do for 1 to 10. Observations 1 to 10. And once you are done, raise your hand. Remember, that's what you are doing you are doing the classification. Now, this is a hypothetical classification anyway. But you're doing it. When you are done with all, you let me know. Piano is done. Keep your hand up. Darkon is done. Olivia is done. Magnus, Mayomi, Naadede, Obriyeboa, Winnie, Michael, Marion, Judison. Here, Hatiatu, Abigail. If you are not done, don't raise your hand because I'm going to call you to mention any one of them for me. Somebody's hand is gone down. There's a obo chrono. Chrono mapana obo. Mekan walo wansa. Chrono and I would namu yes, I would miss hand.
Prof, talk to me directly.
I don't know the person. I just,
Prof, it's me, but I'm done.
But why will you lower your hand? When I said that, no.
Well, the funny thing is, immediately I lowered my hand. That's when you started this one. Like,
So you lowered your hand to check what I was saying?
No, like I was done. I was almost done. So like, I was like, let me just quick, no. Then he said it. So it's just how okay, it's funny. It's very funny.
Okay. So let me pick one. I will mention the customer name. You tell me whether the customer is classified as default 1 or not default 0. So, David Nate, customer number 5. Tell me. Sorry?
1.
1. Very good. Hatiatu Halidu, customer number 4.
Number 4. 0.
Portia, number 8.
0.
Michael, Mark, number 2.
1. 1.
Okay. 1. Very good. Now let's move on. Lower your hand. You are going to build a confusion matrix. Draw the confusion matrix. Build it. It's a 2 by 2 like this. It's a 2 by 2 like this. Like this. And remember that I also need the totals. Okay. I need the totals. So when you get to the end, give me the totals here. When you get to the end, give me the totals also here. So I need some numbers. Okay. And the numbers I need them in such a way that you're going to write them here like this for me. You're going to mention them. Oh, and you're not cheating. Please, if you're finding it somewhere, chat, Google, note, anything. You're not supposed to cheat. Don't cheat. What any cheat is not utiya. So I beg. Make you not teach. So I need you to fill in spot number 1, spot number 2. Let me make it thicker. Fill in spot number 1, spot number 2, spot number 3, spot number 4, spot 5, spot 6. Oh, I'm not even done. I need this one here. And then I need spot 7, spot 8, spot 9. I need you to find me the numbers. Using the table you wrote, remember true, positive, true, negative. Okay. When you are done, raise your hand. When you are done writing that confusion matrix, raise your hand.
I want to ask a question.
Nobody is done. Raise your hand when you're done. If you are confused, ask so, because it's a confusion matrix.
This is Winnie. It seems I got confused.
What did he say?
I have lost my voice. I got confused.
If you got confused, you should ask what you are confused about. But to say I got confused, of course, the whole thing we've been talking for an hour, you say you got confused.
I've lost my. I'll type. Okay.
Okay, so let's start. The number that is at number 1, the name is true positive. Do you agree with that? True positive. So how many were true positive? How many were the true positive? You predicted that they were going to default. They actually defaulted. Fiano?
The true positive is 3.
So you say this section here is 3.
Yeah.
Okay. Then let's go to true negative. This section here. True negative. You predicted that they were not going to default. They did not default. How many were those true negative? Miami.
So 4.
4. And by the way, let me just go back here so that those who might be confused will not be overly overwhelmed. Okay. So when you go here, this is the result. You predicted, that is a true positive. You predicted that this guy was going to be 1, he was 1. This guy was going to be 1, he was 1. This customer was going to default, he defaulted. That's it, 3. Why 3? Because there's nobody that you predicted was going to default 1. This one was going to default, but they failed, so they are not part of it. So true positives were 3. True negative. You predicted that this guy is going to not default. He didn't default. So you're right. Not default, he didn't default, you're right. Not default, he didn't default, you're right. Not default, he didn't default, you're right. So those true negatives are 4. That is what Mayomi just said. Now let's go to the other one, the tough ones. False positive. Now, false positive obviously is going to be in the bottom left corner. Okay. Remember, we have filled in the right diagonals. The right diagonals. Now, the left diagonals from bottom up, the bottom one, bottom left, that is a true negative. So who can count the true negatives here? True negatives are those that you predicted that they are not, the bottom left is true positive. True positive, take note. True positive, bottom left. So you predicted that these guys are going to default, but they did not default. How many were they? Yao.
Dog 2.
2. Which customers?
Customer 5 and 6.
Good. So you predicted that the X guys are going to default with a 1. They didn't default. Okay, so there are 2. Then on the top right corner, the false negative, you actually predicted that they are not going to default, but they defaulted. They are not going to default, but they defaulted. Who was that? Miracle. Which customer?
Sir,
Customers.
Customer 4, please.
That's number 4. Very good.
Yeah.
So
So please, I
guys,
have a question.
mhm.
From the solution guide, where are you going to place precision?
Oh, precision, we haven't come there because precision is going to be a calculation.
Okay, sir. Thank you.
So let me just show you here. So this were the true positive were 3, false negative were 1, false positive were 2, and then true negative was 4. So this is it. Then we put them into the matrix here on the right. And then you have this. Okay. So true positive 3. Now you can add them vertically and horizontally, and you will know the totals. So vertically, you add 3 plus 2, you get 5. 1 plus 4, you get 5. 3 plus 1, you get 4. And then 2, 4, you get 6. And then you get a total. They should all match together. So this is a confusion matrix you've just drawn. You got to learn how to draw a confusion matrix based on something like this. Please lower your hand unless you have a question. Johnny. Okay. So now, based on this confusion matrix, let's go back to the question. The question says, build a confusion matrix. That's B. Now look at the C. Compute and interpret the metrics. So let's focus on the computation. Let's calculate accuracy based on the result you have. Calculate precision. Calculate recall. Calculate F1 score. So let's start. This time you all have your formula, so you don't ask me where is the formula. So based on this result, I've even indicated which one is true, positive, how many are. Use the formula to find accuracy, precision, recall, F1 score. When you are done with accuracy, raise your hand. When you are done with accuracy, raise your hand. You remember the formula for accuracy? You all wrote it, right? I know somebody will wish that he had not written it. They will say that, oh, I've forgotten what I wrote. And yeah, wow, JJJ. Piano, have you gotten your accuracy?
Yes, sir.
What was your answer?
0.7.
In percentage?
70%.
70%. I wonder. That doesn't look good. Emmanuel,
Yes, 70% accuracy.
70% accuracy.
Yes, sir.
Mayomi.
70%, sir.
Okay, good. Now let's go to precision. What did you get for your precision? Johnny Agri.
No, 0.6, please. That's 60%.
60%. That's correct. If you are not clear, you ask, what did you get for recall? If you are not answering, lower your hands. What did you get for recall? Yeah.
Look, 75%.
75%. Okay. So most of the answers that you are getting are correct. Okay. And this is the recall. What did you get for F1 score? F1 score requires a bit of manipulation.
Doc, I have a question, please.
Mhm.
So I think the question spoke about computing the metrics and interpreting it. So I wanted to know how you want us to interpret it. So
I'm
if
coming to that. Don't worry.
Okay, so
Have you finished your F1 score?
no, sir, I'm still on that.
And you're jumping the gun. Yeah.
Doc, 67%.
Emmanuel.
66.7%.
Yeah, so it's 67. Okay. So your F1 score is supposed to be 67%. Now, if you didn't get it, no problem. Look at how it's being calculated. Just look at it. Just look at how it's being calculated. Okay. Now, let's try to interpret them one by one. 70%. Out of the 7 customers, how many were predicted correctly? 70% of them were predicted correctly. That's the accuracy. Okay. So the model correctly classified 7 out of 10 customers, correctly classified them. That's cool. Okay. Now, the question is whether 70% accuracy is good. Well, that depends. But generally, it's not that bad. But the accuracy alone is not enough. We said it before. Anytime accuracy doesn't tell us the type of mistake, it just said that, this was the mistake, but it doesn't tell us. It doesn't tell us the type. That's why we need to go and check. And this is banking. In banking, misclassifying a defaulter may be more serious than misclassifying a safe customer. Suppose somebody is a defaulter and you didn't classify the person well. Hey, and the person, is going to default, but you didn't know. You didn't classify the person as defaulter. Okay. And then you give the person 1 billion. You have collapsed your bank. So accuracy is not enough. Accuracy is not enough. That's why we need to go to the next one, precision. So you got the precision to be 60%. What does that mean? It means that of all those customers that were predicted as defaulters, 60% were truly default. Now you're going into precision. First, you said that 70%, were defaulted. But of those who were truly defaulting, 60%, and the 40% were wrongly denied credit. That is what the 60% imply. Now, which means that the bank has made an error in rejecting 2 good customers out of every predicted defaulters. That is a serious situation. Now, imagine those 2 good customers could have actually increased the value of the firm. You've thrown them away. So precision helps you to measure the trustworthiness of the positive predictions. How trustworthy? You've done a positive prediction, but how comfortably trustworthy? How integral are they? So 60%, that one too is a bit low. Of course, it did well, but 60%, it depends. It depends on, the structure of the bank. So last for the 2, precision. So you were looking for interpretation. These are the interpretations of them. Then you had a recall. What was the value of the recall again?
75%.
75. So what does that mean? Interpret it. It means that out of all the actual defaulters, the model caught 75 of them, which is not bad. Missed 25, which is also serious. Serious. So every, one out of 4 defaulters was not found. You could not detect them. And yet they are going to, default. What is recall doing? Recall is calculating the ability to detect risky guys. That's what recall is doing. But he could not detect 1 out of 4 guys. In banking, that is dangerous. Can cause financial loss. So that takes us to F1 score. F1 score balances precision and recall. We know that. We saw that it gives us a number which is 67, a middle of the two. A middle of the two. So F1 score is a moderate value. Very useful when there is imbalance data set. Okay. And both the false positives and the false negatives, they matter because they are in this F1 score. When you check the formula for the F1 score, they are there. So that is how you calculate each of those metrics. At the same time, you find their confusion table. Okay. That's not the only thing. The other thing you need is a receiver operating characteristics curve. The receiver operating characteristics curve. It also helps you to be able to find the best prediction or to be able to do proper classification. It's used to assess the performance of any binary classification model across all possible classification thresholds. You remember we said that in our own, we selected what? A threshold of 50%. So, and we said that anybody above that cutoff point, that person is going to be classified as default. Anybody below that cutoff point is going to be classified as, okay, why did you choose a 0.5? Okay, why don't we have a whole threshold of between 0 and 1? Yeah, give us a threshold of between 0 and 1 so that we know everything that is happening. Then at each of these thresholds, tell us what is happening to the correct classifications, what is happening to the incorrect classification. Tell us which classification is going to be based on the confusion matrix, which one is going to be wonderful. Which one? So the receiver operating characteristics is very powerful. And what it does is that on the y-axis, I'll show you very soon, but I want to show you something. On the y-axis here, it will plot the true positive rate. Okay. The true positive rate. That is the top left of the diagonal. And then on the x-axis here, it will plot the false positive rate. Remember, the true positive rate is the same as the recall. The recall. And then it will measure the model's ability to, in this case, rank fraudulent observations above legitimate observations across the threshold, across each of the thresholds. And you're going to see, across each of the thresholds, you will have that. Okay, now let's look at the formula for finding the true positive, because that's what you use to plot the curve. So how do you get a true positive rate? Well, as you see here, the true positive rate is simply something. Who can see which formula this is? There's another name for it. Who can remember this formula? This true positive rate? Who remembers the formula, Fiano?
I think it's the recall formula.
Oh, no. Opele.
Yeah.
Ope. Oh, Debbie. Opoku.
Dog is
Don't
the
guess. Oh.
specificity.
Hand
Specificity.
off. Hand off. I said don't guess. Yeah, guess. You are guessing, and that's why you are getting it wrong. Judison, have you finished checking? Don't worry if you have. Just answer me. Have you finished double checking?
Yes, Prof.
Good. Tell us now.
Prof, sensitivity.
And which one is the sensitivity? What's the name?
Oh.
What's the name of that sensitivity? You thought that when you change the name, then it becomes correct.
Oh, Prof, the recall.
It's a recall. So were
Prof,
your colleagues wrong? Were your colleagues wrong?
Yes, Prof.
Kwame, bring out the judgment.
Yes, sir, it's recall or sensitivity. Tofiano was actually correct.
You see, he said that is wrong. So that tells you that he himself, no, he wasn't listening to others. You get it? So take note. It's a recall. It's a recall. So that is a recall, but that is not the same as the specificity. The specificity, we actually didn't calculate it, but we had it. Okay. And the specificity is given by this formula here. That is a false positive rate. So you take these two, the true positive rate, the false positive rate, and then you create your receiver operating characteristics. So watch something. First of all, we indicated that it is giving you the cutoff point probability for all. So you see that it is plotting the recall versus the specificity. And you can see that at different classification thresholds, the further away at the top of the curve, the better. Because when you come to the down, the true positive versus the false positive rate, you know, you see that they are getting smaller. But the further away you go, they are getting what? Larger. But not just getting larger, they are all getting to 1. And 1 is the perfect classification. So if you lower the classification threshold, okay, it will classify more atoms as positives. And that will increase both false positives and true positive. And so this ROC, what it does is that it's very, very good because at least you have multiple cutoff points and it's better. It shows that better performance is reflected by the curves that are closer to the top left corner. The top left corner, the corner section. And you can see that there's a bit of corner here. Here, there's a bit of corner and there's a bit of corner there as well. We'll look at it practically. Now, why are they good? Why are the receiver operating characteristics good? Well, because they are evaluating the model across all thresholds. That's why it's not just 1.5. Also, you can compare different classification models objectively using that trend. And then you can help choose an appropriate decision threshold. And also, they are independent of the class distribution, which makes them very robust in real-life market systems. The other curve is the area under the curve. Now remember, the ROC is the boundary of the space. The AUC is the space. So the AUC is measuring the model's ability to distinguish between the positive and the negative classes. It gives you an aggregate measure. A value closer to 1 is perfect prediction. 100% prediction. Okay. And a value whose a value that is closer to 1 gives you 100% correct. And a value closer to 0 gives you a very wrong information. So anytime you are checking your value and your value is about 0.9, that is hallelujah. AUC. That is hallelujah. A big hallelujah for you. Okay. So let me give you a bit of a range. Okay. We've indicated that the ROC is summarized by the AUC. The AUC is an actual number. Okay. And it tells you the model's ability to distinguish between positive and negative classes. So if you have a logistic regression model, and then the AUC is 0.94, okay, a decision tree model has got an AUC of 0.87. A k-nearest neighbor has got an AUC of 81%. Which one is the best? Which of these models now would you say is a better classifying model among these three? And this is what we do. Among the three, which one is best? Is a logistic, okay? Logistic distinguishes between the two classes better than the others. It has the highest probability of ranking a randomly chosen positive case above a randomly chosen negative case. And these are the ranges of the AUC. Okay, so 1 is perfect classifier, below 0.5 is worse than random. You don't want to go down that pathway. Okay, so in your long essays, you're going to use some of these things to judge the efficacy of the model you have built. It's also important to understand these two models. Remember, I've already said that 1 is best and worst is 0.5, below 0.5. So it is what it is. Don't just try and justify. Okay. Now, there is something called area under the precision recall curve. It concentrates on the minority positive class. Now, the disadvantage of the AUC is that it can mislead you if the data is imbalanced. It can mislead you. It doesn't also directly reflect precision. Precision may be more important in some applications. And that is why you always have to try the precision recall curve. Okay, so now let's go into practicals. Practicals is my interest. So I'm just going to go out here and open the information that I gave you. And you want to do the same thing. Open that information. And in that data info, where is that? There is one of the results I have. One is called accident data. If you open yours, you'll see accident. And I've given you the data. The other is called universal bank data. Guys, tell me, we can't do both. So let me know which one we should do. Of course, that accident data is a multi-class model. And then the universal data is a binary classification model. That talks about all the details. Both of them talk about all the details. Should we do the accident or we do the banking, the universal banking? This is the universal banking. Pick one, Yanko. Class rep, is it Kwame? Kwame, who is the class rep?
From the class rep for finance, Abigail is a class rep for the cohort 3 for supervised.
Is she here?
Yes, Doc. Oh, good morning.
Oh, don't good morning me. What is good about the morning?
Okay.
As a class rep, you are supposed to be talking and answering things for the class. You ask a question, nobody answers. The class rep is your responsibility to stand in for the class. But you are not. And our class rep now, oh yeah. Do you need an assistant?
Please, I have an assistant,
Who?
Caleb.
Okay. Let's move on. So let's look at Universal Bank. You have the data. So this work we are going to do, it was originally developed to illustrate customer targeting. Watch the word, customer targeting. Predictive marketing in banking. You know the accident data, we didn't look at it though. Unlike the accident data is a multi-class classification. That one, the dependent variable are 3. 3, 1, 0, 0, 1, 2. This one is a binary classification model. The file is known as Universal Bank. It has 5,000 customers of this Universal Bank. It's a very young bank and is growing at a massive rate in terms of overall customer acquisition. They are getting customers left, right, and center. It's just like my business that I run. Do you guys know the business that I run? Does anybody know the business that I run?
Yes, prof.
Tell them the business that I run.
Please, it's a consultancy.
No.
Or cloud backup.
No. You see, you thought new. You are trying all means possible, isn't it?
No, you see, you have a lot of things going on. So
who knows?
New clam. Are you talking about new clam?
Yes.
Okay.
You know what that is, right?
Yes.
So the speed at which this customer base is growing, that's the same thing. For example, I started Newcom just 81 days ago. 81, and I have customers of about 1,007 in 61 countries. Me alone. So is that a rapidly growing in terms of our customer acquisition? Aubrey?
Yes, prof. Say it's a rapid growth.
61 countries. That's really rapid.
Yeah, for 81 days. It's very rapid.
For 81 days. And $50,000 in 50 days as well.
Yes, prof. But then I have not seen some.
Oh, don't worry, you will. Portia, are you here?
Yes, Prof.
Okay.
Yes, Doc, I'm here.
I'll be calling you very soon, so get ready. So the majority of the customers, UB customers, are liability. What does that mean? They have varying sizes of relationships with the bank. The customer base of the asset customers is very small. And the bank is interested in growing the customer base as quickly as possible in order to bring more loans. You see, people are doing deposit, but they want people to take loans. Because do you know that when people do deposit, the bank doesn't make a lot of this thing until they collect loans. Are you guys aware of that? And you know that normally the people who collect your loans are usually your customers. Do you know that? As a bank.
Yes, Doc.
So now you have over 5,000 customers and they are all depositing. They are depositing. The customer base is rising, but no one is collecting loans for you to charge them interest to make more money. So the bank wants to explore. We want to explore ways of converting its liability, because the deposit are liabilities, the liability customers to personal loan customers. Ajalada. How can they do that? Well, we know that the bank has many deposit customers. We know that, but relatively few borrowers. And since loans generate higher profits through interest, the bank want to increase the number of customers taking the loans. Now, rather than sending loan offers to all the 5,000 customers, which in fact is very costly and inefficient, the bank want to identify those most likely, watch the word, most likely to accept a future personal loan offer. Now, this is a classic target marketing problem. That's what we're going to look at. You got to discuss your long essay like this. So, in total, I didn't want to go into how to, waste time, but this is it. Let's look at the data. The data is made up of customers' response to the last personal loan. So you have personal loan, and the personal loan is a binary classifier, a binary indicator. Why? Because watch down here. It is one when the customer accepted the loan offer. We are looking at the last personal loan. So you gave loan some time ago, the person accepted it, which means the person is likely to accept again. And then you gave loan, they have tried to give me loans. Last time I was even entitled to 5 million, but I'm not interested. I'm not accepting. I rather want them to, use mine. So they give you some of these things. Look at how many. 0 means that the customer has rejected the loan. Okay. Now we have customer demographic information. These are the predictors, the features. Age of the person, income of the person, the customer's relationship with the bank. Is a person doing mortgages? Is a person doing securities? And so forth. Now, out of the 5,000 customers, only 460, that is 9.6%, accepted a personal loan offered to them the last time. That clearly tells you that we are dealing with imbalanced data, isn't it? Who can tell me why we say that we are dealing with imbalanced data here? Quickly. Why do you think we are dealing with imbalanced data, Abi?
Because the number of people who accepted the personal loan
Sorry, I
are
lost
less
you.
than those who did not accept. Doc, please, can you hear me?
I can hear you now.
Please, I was saying it's imbalance because out of the 5,000 customers, those who were classified as like those who took or accepted the personal loan is few compared to those who did not accept.
Good. So, guys, it means that the data is going to say, our goal now is to build a predictive machine learning model that will identify customers who are most likely to accept the loan offer in future emails that we send to them. Guys, this is a whole long essay project that you are doing. If you have this data and you have this research question, your job is done. I can teach you literature review, introduction, all of this. Now, the target variable is personal loan. Now, look at the available predictors. Some of them are age of the customers, the years of work of experience, the annual income of the customer, okay, the zip code, the residential code, family size, all of them are in there. The educational level of the person, whether the person has taken a mortgage and the amount of the mortgage, whether the person has securities of account, whether the person has certificates of deposit, whether the person is an online banker, on whether the person has a UB issued, Universal Bank issued credit card. All of these are the predictors we are going to be dealing with. Guys, are you with me so far? If you are, say yes. If you are with me.
Yes.
Okay.
Yes, sir.
Let me see my hand. Those of you have opened your Jupyter notebook. If you have opened it like I have, let me see my hand. Let me see. 7 people. Hold on, let me take some screenshots. All of a sudden, let me take some screenshots for the 7 people. The number now goes to 15. Meanwhile, they could have raised a hand in the early 10 seconds. I'll tell you to show me your screen very soon. So if you have opened it, keep your hand up. If you have opened it, I'll do a random quick and I'll say that show me your screen very soon. And when I say that, don't tell me that your internet is wrong. I'll show you, let you show me the screen. Then if you have not opened it like this, now I'm going to make some of your co-hosts quickly to show me your screen. You see, 2 people have left all of a sudden. Eli, show me your screen. I've made you a co-host. Portia. No, let me take. Eli, are you there? Eli. Eli is not in my class. Okay. Eli is not in my class. The number has reduced all of a sudden. Vimino intro kwan adenam wiase na we den trosan na mo abeden wa kwa wani mo abadabum. Obri abo tell them say momo mfa ntro mama mo nsa so why. Obri ana no crack on.
Prof, I'm here. Prof, I'm here.
Tell them they shouldn't raise their hands when they know very well they are lying. Why will you do that? And you see, that's why when I called some of them, they could not even respond. Okay. So here's the first one. It's a regression model. Acceptance. Please lower your hands. Acceptance of a personal loan. So you got to import your packages. The first package, and please note, your first package here is NumPy, Panda, scikit-learn, all the column transformers. One hot encoding will be done, standard scalar, train test splitting. This is logistic regression. Okay, and watch the accuracy measures we are going to be dealing with. Please lower your hands. The accuracy measures that we are going to be dealing with. The first accuracy measure is accuracy score. We will do the classification reports. We'll do the confusion matrix, the AU score, the ROC. Okay, so all of them are here. Okay, these are the metrics. Then we'll also do some graph. So we will now bring in the matplots, like the pie plot. So let's load the data. This is a universal bank data. Use a normal approach to load the data. We'll print the dimensions of the data, the first 3 observations, and the last one. Now let me show you that result quickly before we proceed. Okay. The first 3, it does code knows. So this is it. This is the data. You have 5,000 rows and 14 columns. The first 3 observations are as follows. The ID of the person, the age, the experience, the income, the zip code, the family, the CC average, education, the mortgage, the personal loan. That's our target variable. The securities account, the certificate of deposit account, the online credit card account. So these are it. These are them. And you can see that with missing values, there's no missing values. All of them are intact. But then there were 13 duplicate values. 13 duplicate values. Now let me just go back quickly. So look here. You see that remove identifier. So this way are removed. The ID, the zip code, the COD, all of them were removed. Okay. Then we did data quality check for missing values, for duplicate values. And then we even printed the distribution of the personal loan. Remember, the personal loan is 0, 1, and it is a dependent variable. We'll look at the prediction of it, as well as the count, as well as the percentages. Okay, let's check the results for that one first. There you go. So you see that the personal loan, these are the distribution. 4,520 were not default, and 480 were default. In fact, I've made some comment on that here. It's all here. It's all there. Where is that temple? Yeah. So those ones are very, very easy and cool. And then you can see that the personal loan, okay, in terms of percentage, this is the same thing here. The same thing here. Almost 90% were not defaulting, and 10% were defaulting approximately. And this is interesting. The number of customers with negative experience. I'll come back to that. But let's just go to the code, because I also want you to understand the codes that are happening here. So after this, we come to check negative experience. Okay. So you have negative experience for the bank. You can have the negative experience for the bank. Okay. And in this company, it has a very small number of negative experience values. Now, what is this negative experience value? Let's just quickly talk about that first. So, it's here. I've made some points here that I want you to know. One methodological caution is that if you standardize the predictors, it means that the coefficient of the continuous variable will show the effect of one standard deviation rise instead of 1 unit. So this will improve. So that's why we use the standardized predictors. But my point is this one, the number of customers with negative. 52 customers have impossible negative values. Negative for work experience. What does that mean? It's obviously data error. Okay. So these values will have to be corrected. They will have to be replaced, or they would have to be documented before you undertake the modeling process. You wouldn't see it, but because we looked at whether there are errors, it has told us whether there are errors. Okay, now let's go to the education variable. That one was here. So when you check the education variable, where is that? Here. So the education variable has been split into 3. You can see that we have undergraduate, graduate, and then professional. So when you take education, there are classes, and we classify them. That's why you see that education contains values other than 1, 2, or 3. So classify that. We set the category so that the undergrads become the baseline. So you always talk about the undergrad, everything relative to the undergraduate students. Okay. Now, regarding that, I've made some comments on that here. What did you say? That the education variable has been successfully converted into 3 categories. 3 categories. Undergraduates, out of the 5,000, the undergraduate students the undergrad customers are 2,096, very, very large. The professionals are 1,005 customers, and the graduates are 1,004 customers. So undergraduates are the largest educational group, representing almost 42% of the total customer base. Now, why do you think that is good, important to know? Because sometimes it helps you to know which particular group is actually affecting the likelihood of future personal loans. That's what it means. Okay. So That is a bit of the categorization that you should know. Let's go and run the model. Now, before we run the model, it's good to identify the types, the continuous variables that are in the model. These are them: age, experience, income, family, CC, average, mortgage. Then the education variable, we've spoken about it. Okay, the education is categorical and requires a dummy. So that is generated. And then these variables have already been coded as dummy. Okay, so we just want you to know that they have already been coded as dummy. These are the binary columns. We are letting Python to know. Now let's do a train split of the data. You do a train split. I did all of these codes, okay, generated them together. We get it all together, combined, but you need to understand what is going on. We use a test size of 30%, which means the training is 70%. We use a random state, which doesn't force the split to have any challenges. Okay. We use stratify. Why? Because if you use stratify, anytime you do the train test split, you still maintain the same number of people or customers that have been classified into the tests and into the training. You don't split them. You don't change them. And then, as you can see, we printed the results for that. So look at some few information about the results. So this result, let me show you something. The first result you get, in fact, let me just show you the code for the confusion matrix before we show the results. So you do the train test plate, data pre-processing is done. We first drop the undergraduate because it was defined as the first category, the base model, the reference category. Okay, so the undergraduate becomes a reference group. So we got to do a code to drop that. Then you build a logistic model. Okay, you create a logistic classifier. The classifier here is one per just logistic regression. Then we fit the model, as you can see here. We fit the model, and then you generate a prediction of the model. Watch it carefully. In the prediction, you see that the probability that a personal loan is equal to 1 is made. And this code sets that. So that 1 means we are predicting the probability of default, not the probability of non-default. Okay. In this case, we are talking about loans, personal loans. So we are predicting the probability that a person is going to, accept the personal loan. Okay. That is the value. And then you get a confusion matrix result. So we first generate a confusion matrix here, and watch carefully. The confusion matrix is not based on the training set. As you can see, it is based on the test set. It's a test, it's a predicted test set. Okay. Because the training set, if it is good, then the evaluation must confirm that the model is truly good. And then we created a classification report, which I'll talk about this classification report very, very soon. And then finally, we generated the coefficient of each variable. And then we'll generate the, retrieval operating characteristics curve, okay, to get the entire false positive rate and then true positive rate. We generate that, have the results, and then find our AUC plots and everything. The sample prediction results are all generated here. Okay, so my interest is this first one, the confusion matrix. That is my first interest. Where is that? Okay, so when you look at a confusion matrix, what numbers do you see? Okay. Which are the numbers for the confusion matrix? Do you see the true positive? Guys, just quickly seeing the true positive to be 1,342. What does that tell you, Ampere Miracle? What does that tell you? Ampere, your hand is up.
Yeah, Doc. Yeah, I was answering the confusion matrix as in the true positive figure and the false negative, as well as the false positive and the true negative. Yeah. So the 1,342 tells me the number of record that was classified correctly.
Is that good or bad?
It's good, sir.
Very good. Now watch this. I've made some good interpretation of that here. The confusion matrix is actually quite good, especially if you look at the 9.6% of the customers that accepted the loan. You see that number. I'm sure you remember the number. However, it's important to interpret it. So there's a number. Now, so when you go into the true positives, Oh, this one he uses, okay, is the way he put it. Is the way he organizes it. Because he brought the person not collecting the loan as the negative, and the person collecting the loan as a positive. So the true negative is 1,342. Okay. And remember, that 1,342 means that there are customers who did not accept the loan. Okay. And then the model has correctly predicted that they will not accept the loan. No. So at least the model has won, and is the largest group. Why? Because approximately 90% of the customers rejected the loan in this very example. Now, remember that the whole idea is to find out which customers are going to accept the loan or reject the loan in the future. In the future, not now. Okay, in the future. And because 90% of the customers rejected the loan, before, and then 14% actually rejected the loan. And you can see that that's a false positive. Okay, so that's why I say no loan, no loan, and then loan. So the bank, the customers that actually rejected the loan, but the model has already predicted that they will accept it. So here, the model, they have predicted that they will accept the loan. They will go for loan. But then here, they didn't go for loan. Okay, so that is 14. That is not that much. And then here, they've predicted that they will not accept the loan, but they actually accepted the loan. Now that is interesting. That is very interesting. But before that, let me go here. This one here. Those customers, okay, who were predicted that they will go for the loan, but 14 didn't go for the loan. If you look at it, remember, we are looking at future marketing. Okay. If you look at it from marketing background, the bank will send loan officers to these guys. It will do that to those 14 guys unnecessarily. Okay. Because the cost of sending loan officers to go and convince them to do the loan, the cost is quite small. There are only 14 customers who were incorrectly targeted. So the false positive is very low, it's just 14. So they will take that action. It's not going to cost a problem. Then you come to here, those who were predicted that they will not accept the loan, but they went for it. Now, if the model predicted that they will reject it, but then they went for it, it's a very, very costly error. Because they are 47 and they are more than the 14. Why is it a costly error? because the bank will not send a loan officer to these guys anyway, because they've already predicted that they are not going to go for the loan anyway. Therefore, the bank will lose potential loan business. People who wanted to do the loan, but they rejected them ahead of time in their head, and that becomes like a missed opportunity. So that is a bit of a worry. And you see that this false negatives is going to affect the score eventually. Just one of the score, okay? And then you have the true positive. The true positive, the 97 true positive here. So these were people who the bank predicted that they will take the loan, and they actually took the loan. Okay. They've been well identified that they will take the loan, and they did it. Now that those customers are the customers the bank wants to find. I am saying that you are going to take it. You actually took it. I need to see you. So when you come down here, you will see that when you add all of these information together, you get the true test data, which confirms that the test truly contains 1,005 customers, consistent with a 70-30 train test split. So that is good. So what will be the conclusion here if you look at the information percentage-wise? Well, again, when you go to the results, check the results here. It's not just these numbers that were found. They were also indicated classification report, Ankasa. So these are the classification report calculates the metrics that we did, for the precision, for recall, and all of that. This is it. This result, you just pick them and take them into your notes, your data set, and interpret them. Already, we are having ROC, AUC of 0.9. That shows perfection. We'll come back to that. So, let's first interpret the accuracy score. That is 0.9593. You can see that here. Where is that? Accuracy score of there you go, this one. So that is an accuracy score of 0.9593. Now, the one we just did some few minutes ago, some of them were 60, 75, and all of that. Well, the sample size was small. Here, you can see that we are talking about anything above 70. So what does that mean? The model achieved an overall classification rate of 95%, correctly classifying 1,439 out of the 1,005. That was correctly classified. Now, we've already said that while this indicates excellent overall score, accuracy alone is not enough, if you remember. It should be interpreted alongside the other performance metric, because 9.6% of the customers accepted the loan, resulting in an imbalanced data set. So that is something to look at. And then, for customers who didn't accept the loan, okay, watch it. Only for customers who didn't accept the loan. And you can go to the results and you see that here. Here. For customers who did not accept loan. Look at that. Look at the figures. Every single one of them is above 96%. You know what that means? Okay. So the model has performed exceptionally well. It has achieved a precision of 96.62%, which shows that almost all the customer predicted to reject the loan actually rejected the loan. Now, when you check the record there is 98%, which shows that the model actually correctly identified nearly all customers who rejected the loan. And then when you check the F1 score, for those saying did not, you see that it's also almost 98%, which shows an excellent balance between the precision and the record. You will notice that the F1 score is always like that. It's always going to be dancing between the precision and the record. The record is bigger here. Usually it is 99%. Precision is 97%. And you can see that F1 score is 98% in between the two of them. That is for those who didn't accept the loan. Fantastic. We are winning. But for those who accepted the loan, and again, go here and check it. For those who accepted the loan, here, These guys accepted the loan. By the way, those who accepted the loan, you can see out of the 1,004, this is it. The support you see at the right side is talking about out of the 1,005, 144 accepted the loan, 1,356 did not accept the loan. Okay. So we are talking about those 144 for one. The other ones. Out of that, look at the precision rate. Okay, it's not that bad. The only thing is a record. We'll come back to that. So out of that number, okay, the model achieved a precision of 87%, which means that when the model predicted a customer would accept the loan, it was correctly approximately 87% of the time. But, now the record. The record is just 67%, which shows that the model identified only 2/3 of the customers who actually accepted, missing the remaining 1/3. Now that is not that great, but we have a F1 score to balance the thing. So the corresponding F1 score of 76% shows that even though the model predicts loan acceptance with good precision, there is room for improvement in identifying all potential loan customers. And when you go to the thing, you also see the macro average F1 score. Look at the macro average F1 score, this one here. Okay, that is for all of them, all of those guys that are in the test data. 92% under precision, 83%, 86% under recall and F1 score respectively. You know what that means? It means something very profound. It shows that there's a good performance across both classes of those who accept and those who don't accept. When each class is given equal chance, that's what happens. 95% average is higher. Why? Because majority dominates the data set. The customers who didn't accept the loan, they are dominating the data set. Finally, let's look at the ROCAU curve. Okay. In fact, you can see the value even there. Let's check it first. So this is a ROCAU value. And then you can see it here as well. The fact that it will draw it, and you can see that it is pushing towards 1. That is a curving. See the way the thing is here? It is pushing towards 1. Okay. And its mirror image is also towards 1 here on the false positive rate. It's pushing. And you want it to be pushing towards 1, section where the curve is bending. What do you notice? Okay, well, the value of the AUC is 0.9. And remember, remember that we said that anything below 0.5 is bad. Anything above 0.95 is excellent, if you remember the threshold criteria that we gave. So, since the AU values, which ranges from 0.5 means there's no discrimination at all between the classes. 1 means there's perfect discrimination. With our 0.97, it shows excellent discriminating ability, which means that the model is highly effective at separating between customers who are likely to accept the loan from those who are not or who are likely to reject the loan. It has clearly done a separation of them. Let's look at the practical business ramifications of this. Business-wise, the model provides an effective tool for target marketing. Okay. And this target marketing is within, not without, because it's been able to identify customers who are likely to accept a personal loan, which would then enable the bank focus on its marketing efforts, focus on high potential customers, focus on reducing campaign costs, focus on improving loan conversion rates. The model is very good. It improves, it's good, but the record has to be improved. The record, if you improve the record, you can help identify more potential loan customers and increase business opportunities. Another improvement is the methodology. You have to adjust the classification threshold. We have to apply something we call SMOTI. Okay, a balancing class balancing technique. Something is very good. Or use logistic regression with more advanced models like random forest, gradient boosting, XGBoost. This is only another assumption that I have not done this one for them. All of this can improve the identification process finally. And remember, we are looking at regression. So we have to talk about the coefficients. So let's go and look at the coefficient. Watch the coefficients. These are the regression coefficients. What are we interested in? You see here, we have the variable, we have the coefficient, we don't have the t-statistic because this is not a normal regression. Our only interest is the odds ratio. Odds ratio, because we calculate, if you are writing the logistic regression model, your odds ratio is what you look for. Your odds ratio is like it's like something that will help you analyze the p-value in the normal regression. But then the key point is that you have your coefficient. So let's look at the coefficient before we look at the odds ratio. Okay, that's the last one. So the coefficients indicate the direction and the strength of the relationship between the predictor and then the loan. The odds ratio shows how the odds, what are the odds of accepting the loan challenge in case there's a 1 unit increase in any predictor. So we take, for example, education is the strongest predictor. Let's go and check education. You see education here, in fact, the whole thing has been organized in descending order. Education is the strongest one because the coefficient is the highest, 3.2 or 3.3, basically, 3.297. So that education is doing really well. Not just education. Education is split into two. It's a binary. So you have the education advanced, education graduate. Okay, graduate. And then remember that undergraduate was a reference category. So education is really, really looking good. Let's see what we indicate about education. So compared with the customers having undergraduates, remember I said that undergraduate is a reference category. Customers with advanced education are about 27.1 times more likely to accept a personal loan. Very likely to accept a personal loan. Whilst graduates are about 26.4 times more likely. So you can see that compared to undergraduates, professionals are going to accept a personal loan. Because undergraduate, he's having pocketitis, So he's very unlikely to accept a personal loan. But then the graduates who they are, you see, who can tell me why the graduates' own is slightly smaller than the professionals? Graduates. Why do you think, of course, the graduates are better than the undergrads, but why do you think the graduates are, lower than the professional in terms of the likelihood of accepting loans in the future? I will take a final attendance list before we close. Let them know. Class rep, what time do we close? Eugene, you have a question? Yeah, Eugene.
Bob, I want to answer the question you asked.
Do you know the time we normally close?
I think we close around 12:30.
Okay, all right. Continue. Go ahead.
I'm thinking that the graduates are slightly below the professionals because all professionals are graduates, but not all graduates are professionals. That's
Good.
why that way.
Good. You're right. And it's more likely that most of the graduates have not gotten jobs yet, but most of the professionals, they are already on the job when they went to do the professionals. So they have enough money, that's the point, to be able to, go for a loan, right? Or they have projects that they are more likely to be doing to go for loan for further work. Now, customers with certificate of deposit accounts, if you check the value, it shows that they are about 23.5 times more likely to accept a loan. which shows that the customers with stronger banking relationships. See, certificate deposit account there. It means banking. They are much more receptive to loan offers. They are okay. They will go for the loan. Then those with higher income, if you check income, let's go and check income. So if you check income here, see, it's positive. Okay. So it means that, and that positive value is the odds ratio. Okay. The odds ratio is 11.49. So it shows that a higher income customer is considerably more likely to accept a personal loan. Yeah. All the wealthy people, they always go for loans. Then, if you check family size, credit card, spending, age, mortgage, all of them are positive, which shows that if you should increase any of the age of the family size, they are associated with the likelihood that the person will go for a loan. If you have one child and the children go to 10 children, the likelihood of you going for a loan to go and get a bigger house is high. But then the effects are very modest. Then credit card, if you have a credit card or if you do online banking, okay, it has a negative effect on the coefficient because the odds ratios are all less than 1. Let's go and check that. Those last three information. Okay, experience, mortgage, all of them. Okay, look at in fact, just look at experience alone. You will notice clearly that experience has got an odds ratio less than 1. Less than 1 is a clear, obvious, lower value. Okay, because it shows that the variable is associated with a lower likelihood of personal loan. So if your credit card is increasing, you are not likely to go for a loan. That's the point. And the same goes with the others. So you can make a conclusion that the results suggest that educational level, having a CD account, and customer income are the most influential. Okay. However, here's my point. The importance of each variable should ideally be confirmed using p-values or confidence interval because the coefficient table alone doesn't tell us whether these factors are significant or insignificant. So it'd be nice to incorporate significant values in the process. But we are using this for prediction, so we'll focus on prediction. Okay. Now, one of the things you'll be doing in your long essay, in your research is this, and I want to give it to you so that you learn it, so that you see it in the exam, you are not perturbed. And that is the feature importance of the variables. Which of these variables is the most important? Well, to do that, you first have to install pip install sharp. We use something called the Shapley additive importance or Shapley additive explanation. Okay, the Shapley additive explanation. This will calculate which variable is important in a beautiful graphics. I'm not going to go through this one, but I'm just quickly going to show you the graphics. So watch the graphics. It tells you which variables are really doing some wonderful situation. Remember, we spoke about education, we spoke about income, and some other things. Okay. Now, the higher value, the higher section here, if you are here, it means that the thing is big. Okay. And then if you are down, it means that the thing is low. So that is a Shapley value, the impact on this on the model. Now, there are different graphs. You can use the first one we have just used. The first one is known as the importance of each of these locally. Then the second one here is the global Shapley feature importance. You're going to see is a bar. It will rank variables by the average absolute value, and the larger values will indicate greater overall effect on the model's prediction. So if you check again, income is having a greater over. It's good to have these things planted in your work. That's all I'm saying. you know, and it shows clearly. Let me just lower it a small. It shows clearly that income and the others, are doing pretty well. That's a global Shipley additive explanation feature importance. Then you have the one for, if you want to show how a particular independent variable affects the loan acceptance. One independent variable. So here I'm using what? Numeric independent variable here. How it is affecting the value. And you can see that it's positively, beautifully, affecting the value. Okay. You can check the scatter plot of the others. Okay. This one is a current credit card use. Again, it has a, it has a numeric relationship with the Shipley value of itself. And then you can look at others. I'm not so much in there. I'm just interested in the first one. Then you can look at the local explanation for one customer. So why the model predicted that a particular customer would or will not accept a loan. One customer. And you can see clearly these numbers will indicate. So if you see the fact that you have education being the highest means that if a person is highly educated, that person, you just take that person's education and loan, and the person is going to go for a personal loan. Because the guy is going to go for personal loan to be able to match up the educational cost that a person is having. In fact, I see that in our PhD admission. Okay, we've never had PhD admission more than 20 in our department. All of a sudden, we threw away scholarship. All the non-Kwahrianum, are applying. And people are applying because they've seen that there's a scholarship there. And then, finally, this is the one I like the most, because it shows clearly the beautiful graph. And you see this even in journal articles. It's similar to the first one we had, but it puts everything. You can click here, copy this, and put it into your thesis or journal. The effect of each variable is just incredible. Let's do a bit of interpretations. Quick one. The features at the top are the most influential. We've said that. And the sharp value greater than 0 will push the prediction towards accepting the loan. So if the sharp value is greater than 0, you can see it. All of this. Those that are greater than 0, you can see them here in absolute terms. In absolute terms. They are the ones. And then the red points represent high feature values. Okay. These ones, high feature values. Those are the ones that you notice for the red points. And then the blue points represent low feature values. The feature values of that income. The feature values of that particular income. And then we can have an example. So if high income observations appear as red on the positive side, it means that higher income increases the predicted likelihood of accepting a loan. So this Shipley additive explanation is very good because it gives you, even though we are not getting the coefficient, p-values and whether it's significant or insignificant, okay, this Shipley measures each feature's contribution to the individual prediction rather than relying only on the coefficient. And that, ladies and gentlemen, is significant. I think you've all seen the ROC already, so I will not show you the graph. Now, this is a summary of the ROC. Okay, it shows that the logistic regression model has an excellent ability to distinguish customers who will accept the loan from those who won't. And as you can see, the curve lies close to the top left corner of the AUC. Of the curve, and the AUC is 97%, which is far above the threshold of 0.5 level for a random classifier. What is the meaning? This means that the model has about 97% chance of ranking an actual loan acceptor higher than a non-loan acceptor. Overall, the model is highly effective in targeting customer segmentation, likely personal loan customers. Even though the final classification threshold should still be chosen based on the bank balance between the mixed customers and unless insurance. Okay, now let's look at the very last one, and then we are done. The very last one is this result here. Whoa. This one took us long. This last one. Customers with I love this last one. Customers with the highest predicted acceptance probability. You can see the customers, 1,500, the customers, wherever they are. The highest predicted acceptance probability. Very, 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 very important to be able to know which customers are kind of pushing the frontier. So that table you saw there list 10 customers with the highest predicted probability of accepting it. Like these guys, they are going to take the loan. They are going to take the loan. They are those customers that the bank should prioritize in the future personal loan. They are going to them. You see, they are using their past information and they will go to them and they will accept it. If you check all of them customers, they have actual value of 1. In other words, they actually accepted the loan. And then they have a predicted value of 1, which means the model correctly predicted that they would accept the loan. They did accept the loan, which shows that the model is highly effective in identifying customers very likely to accept a loan. So that's the first important part of those. The second thing is that the predicted probabilities of these guys is between 0.9931 and 0.9979. Which shows that the model estimates that each one of these 10 customers has more than 99% probability of accepting the loan. Now you are picking the mature people. And such a high probability shows a high level of confidence in the model's prediction. Oh. And then when you look at the fact that these are high potential customers, several common characteristics come from these guys. 1, they have high income. You can see that when you check the income value. The annual income is ranging between 168 to 202. They have high income. Another thing you will see about these 10 customers is that they generally have a very high average monthly credit card expenditure. They are spending $2.3 and $10,000, monthly, which shows greater purchasing power and financial capacity. We look at the educational level. Most of them have either graduate or advanced education. Most of them, which reinforces the earlier point we said that education is a strong predictor of loan acceptance. And then finally, their account regarding certificate of deposit. Most of these customers have certificate of deposit account, which shows that customers with strong banking link are more receptive because they have been dealing with the bank. They are more receptive for extra financial products. So suppose the person is, always using DSTV, and DSTV says, okay, now we are going to be adding this in. They are more likely to take. They are more likely to take. And check, 2 customers without a CD account were still predicted to accept the loan because their other characteristics like income and education strongly increase. Now watch this. That's the last thing to see. If you check the CD account of those people, it will explain. So these are these guys. Their CD account clearly shows that they don't really have certificate of deposit account though. They don't. But because they are advanced professional, okay, because they are advanced professional, this is it. And then look at them. Their income. Their income is very low, very high. In fact, it looks like that person doesn't even have, is the only person with an income above 200. Check it. And it is also the one with a credit card account average of 10,000. So that person is taking 10,000. 10,000 from the credit card every month. And yet that person is not having a certificate of deposit. So you can't say that, oh, because he's not having a certificate of deposit. No. his other features are making him, go for the probability of accepting a future loan. Ladies and gentlemen, that brings us, who can continue for me?
To the end of the caboodle.
That brings us to the end of the entire caboodle. Let me summarize it in one sentence here. The result of this logistic regression is effective in ranking customers according to their likelihood of loan acceptance. Customers with high income, graduate, advanced education, high credit card spending, particularly those holding CD account, are the most promising target for future loan marketing campaign. We are done. Any question?